Hi everyone, welcome to our video on cost, revenue, and profit applications for linear functions. So our cost function is in the form c of x equals mx plus b, where c of x is usually in some type of dollar amount. Okay, so let's go ahead and mark this. So c of x, that's going to be in dollars. Our m is the slope, but again, it's usually with our word problems, either called a marginal cost, or if you see something per something, then that's a clue that it's our slope. And then the b is called the fixed cost. And then our revenue, so r of x, so this is, let me go back, sorry. So it is in dollars. I said cost, but I didn't write it. Let me write it. Cost. Okay, and usually that's in some dollar amount. Maybe it's that. So I say usually. Maybe it's in cents, or maybe it's like in hundreds of dollars or thousands of dollars. Okay, so but usually dollars. Whereas r of x, this is our revenue function. And again, that would also be in dollars, some type of dollar amount. That's supposed to be the dollar symbol. Let me try again. That's okay. That's better. Okay, so that's our revenue is what you would earn if we don't include the cost. Okay, so what's going to be more important for us is going to be profit in a second. So the revenue is what you earn before counting for the cost. Okay, and the revenue is usually based on some price, whatever the price of something is. So P is usually the price per unit. So whatever is being sold, or whatever they're working with, it's a price per unit. So you have to be careful. So this also has per in it, but you're thinking of something that involves sales. Let's go ahead and put revenue. Revenue involves sales. So that's the other keyword that they might use. And then our profit function, so P of x is the profit, which is, again, often in dollars or hundreds of dollars or thousands of dollars. And then profit is the revenue function minus the cost function. Okay, so that's all we have to say about that. So it's all dependent on the revenue and the cost. So let's break down a couple problems here with these three. So in this example, it says producing X units of sandwiches cost. So here they're nice enough to just give us the whole cost function. And they do tell us X units of sandwiches. And the revenue is given as well. R of X equals 5X dollars. Now, instantly, there's some new vocabulary. The break-even quantity. The break-even quantity is the X value when the cost function equals the revenue function. So that means all we have to do is set these two equal to each other. So our cost function is 2x plus 60, and then set it equal to the revenue function, 5x. And then from here, we're just going to solve for x. So we can subtract the 2x to both sides, and we'll get 60 is equal to 3x, and then we divide by 3 to get 20. So we've got 20 equals x, and I'm going to cloud that, and let's put it as a formal answer over here. So what they're saying is to break even, they or he or she or whatever's going on here, so to break even, they need to sell, or they need, let's just say sell. They need to sell 20 sandwiches. Okay, so if they sell anything less than 20 sandwiches, then that means they're losing money because the cost would be more than the revenue. If they sell more than 20 sandwiches, then they are making money. So they're making a profit on it. Okay, so let's see number 2. What is the profit from 50 sandwiches? Okay, so they're asking for profit. So first thing we need to do is just get the profit function. our profit function is the revenue minus the cost. And what would be a good idea for this, let's go and put it in our equation up here too. Let's put the bracket in. So those are implied. So brackets, or you could use parentheses like this. So, you know, they do mean the same thing. It's just different ways to write it. And the reason that we need that is because that minus right there needs to distribute. So we're going to have P of X equals the revenue, so which is 5X. So I'm putting the whole thing in the parentheses. And then minus the cost. Again, put it in parentheses. The cost is 2X plus 60. Okay, so notice it's got parentheses around each of those two functions on the right. And then that way we will distribute the negative. So we have P of X equals. Now the 5X no longer needs the parentheses. It is positive in the front anyway. But as we distribute the negative, we would have minus 2X minus 60. And then from here, we can combine 5X minus 2X to get 3X minus 60. Okay, so there is our profit function. And one thing to just, I would say quickly check, just plug 0 in to see if it makes sense. So if you do plug 0 in, it's negative 60. And that makes sense. So this is telling us if you sell 0 sandwiches, then you just lost $60 because you produced $60 worth of sandwiches, and then, well, they're just sitting around doing nothing. Okay, so that seems to make sense. So that can help with the distributing. So, for instance, if this was accidentally a plus, then we would say, oh, I just sold 0 sandwiches and made $60? That doesn't make sense. Okay, that would be, what a world if that would work, huh? Okay, so let me get rid of it. Okay, so this is just a quick verification. Also, you can quickly check, depending on the break even, sometimes they ask for the break even later, but if we plug in 20, notice it would be 20 times 3 is 60, minus 60 is 0. So we're saying we've got 0 profit so far. So we haven't lost money, we haven't earned money. So selling more than 20 sandwiches, again, that would put it into the positive. Less than 20 would be a negative. Okay, so this is also checking out. So that's another way to find the break even. So when the profit equals 0, that's another way to find the break even point. So profit that's a different way. Okay, anyway, back to this problem though, number 2. So we're still not done yet. They want to know the profit from 50 sandwiches. So that's an X value. So now we can plug it into our profit function, and we'll just sub out the X for 50. And then from here, we'll simplify. So it looks like I'm going into number 3 a little bit. Okay, but let's go ahead and write it as P of 50 equals, well, 3 times 50 is 150 minus 60. That would be $90. Okay, so the profit, let's put it in words just right here to the side. Profit from 50 sandwiches is $90. Okay, that's all you have to do. Okay, so that's in case they want you to interpret what this means in words. Okay, so that's it. So 50 sandwiches made a profit of $90. Okay, so that's our, let me go ahead and cloud. So sometimes they want that individually. Okay, so we needed that to answer the rest of that number 2. Okay, for number 3, though, it's saying how many sandwiches will produce a profit of $300. Okay, so that's a good reason to cloud that, what we just did on the right there. So they're asking how many sandwiches. So we want to know X, how many sandwiches. So we're going to find X when the profit equals $300. And so we'll use our, let's just write it down one more time. So the one that I just clouded. So there's our profit function. They're saying change this right here, change the profit into $300. And then from there, you'll be able to find your X. So 300 equals 3X minus 60. And then now we could solve this linear equation. We could add the 60 over. To save room, I'm just going to do it right there. So if we add 60 to both sides, we'd have 360 is 3x. And then if we divide by 3, well, 360 divided by 3 would be 120. So it looks like 120 is our x. Okay, so it looks like they need to make and then sell 120 sandwiches for a profit of $300. Okay, so that's it. There we go. Okay, so that's how we can find these different cases. So notice we're just making sure we're plugging the right letter or right numbers into the right letters. All right, let's check out one other problem here where it talks about Maggie. So Maggie makes quilts. She finds that her marginal cost is $15, and it says that she can make 40 quilts at a cost of $650. She plans to sell her quilts online for $20 per quilt. Okay, so let's break down this first line. So she finds that her marginal cost is $15. She can make 40 quilts at a cost of $650. And then she plans to sell, okay, so this is a different sell, is non-involving cost, sell her quilts online for $20 per quilt. Okay, so just to mark it in some colors here. Okay, so let's deal with the cost. So what is her quilt cost function? And this is a linear, we'll assume it's linear, so let's put C of x equals mx plus b. Okay, so they do tell us the marginal cost. So remember, our marginal cost is the slope. So we do have that instantly, and we can change it as needed right there if we want to. So, but we don't have the fixed cost yet. The second line here that's underlined, she can make 40 quilts at a cost of $650. So this is telling us our number of quilts. Let's go ahead and get our variables too. So the dollar amounts are the cost or the revenue or the profit, but the number of quilts, let's just go ahead and put this here. X involves the number of quilts. So that's our number of something. So the number of quilts. And then the 650 is going to represent the cost. Okay, so what this is telling us then in this line, they're saying the cost of 40 quilts is equal to $650. So that's how we can break it down in math notation. And so what we could do is say, well, they're saying this here is an X value, and then change the 650 on the left side, or change the cost into 650 on the left side. So we've got 650 is equal to 15 times the number of quilts, so they're saying 40, and then plus whatever the fixed cost will be. Okay, and then from here it looks like we could solve this. Okay, so this is 650 equals 15 times 40 is 600. And then most of the time, again, you use calculators on these things. So if you ever need it, use it. 15 times 40 is 600. And then from here, we can subtract the 600 to both sides. So we'd have 50 is equal to B. And then, well, I want just the cost function, the quilt cost function. So that is in this form. But we'll just combine the letters that we just found and create it as our C of x is equal to, so change the m to 15 and then keep x and then plus 50. All right, there we go. Okay, so that's her cost function, and if we do plug in 40, we could check. If you do plug 40 into there, 15 times 40 plus 50 is 650. Okay, so that's just a very, very quick check. So it does let us know it looks like it is correct. Okay, so moving on though. What is her revenue function? All right, well, her revenue function is based on the sales. So sells her quilts online for $20 per quilt. So the price is $20 is what we could say. The revenue function does have the form P times X. Okay, so, and you don't need to write out this whole form if you want to. So revenue is often really nice, and you could just jump straight to it. So $20 per X. And that's it. Okay, so it's our revenue function is ready to go. So revenue is often easier to find than cost. Okay, and then it does want the profit function. Okay, so our profit function is P of X, and we can write it as the revenue minus the cost. Okay, and with the revenue, it's, again, I'm going to put in these brackets. Those are implied. Those would be there, but math, a lot of times, they don't write some of the stuff that they really should, because we need to do that substitution. So let's go ahead and put it in parentheses. So the whole revenue is 20x, and then minus, and then in parentheses is the cost, which is 15x plus 50. And again, use those parentheses, because every time this minus is going to distribute. And so what it would become is our profit is 20x minus 15x minus 50. And then now we can combine the like terms. 20x minus 15x is 5x, and then minus 50 to the side still, because it's not like terms, so it just stays over there. Just like that. Okay, so there's our profit function. And again, I would do just a very, very quick check. If you just plug in 0, make sure that makes sense. It would be negative 50. So what they're saying is, well, if she sold 0 quilts, she's currently making a profit of negative $50. So she's losing money because she's spending to get the supplies and whatever, and not selling anything afterwards. So yeah, that at least makes sense. Okay, so again, that helps with the distributing. Okay, and then for number 4, what is her break-even point? So you could do it in 2 different ways. You could do it by setting the revenue equal to the cost, or you could do it when the profit is equal to 0. Okay, so just to show both real quick, let's do number 2 first, since we did the number 1 style in the previous problem. So what they're saying is just change the profit function and just have it set equal to 0. So what we just found in the previous step, so 5x minus 50, have that as the profit, set it equal to 0, and then from there we could add the 50 over. So if we add 50 to both sides, we'll have 5x is equal to 50. And then we could divide by 5. I don't think we need to show work for that. I'm just going to say 50 divided by 5 is 10. So it looks like it'd be 10 quilts. Okay, and we could verify if we do set the revenue function. So we got the revenue is 20x, and if we set that equal to the cost function, which we got is 15x plus 50, notice when we subtract the 15x over, we get 5x equals 50, which is so far the same as over there, and x equals 10 would be the answer. Okay, so to break even, she would need to sell 10 quilts. And I'm just boxing the one on the right because it had quilts already written. Okay, so that's how we could break these problems down. So our cost function, scroll back up. Remember the vocabulary that's involved. Make sure those letters are going in the right spot when you replace them with the numbers. Revenue is a little easier to deal with, but they're always going to ask for more in these problems. Okay, so it's often not just plug in and done. Often we need to do a little bit of work. Okay, so that's it though. If you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.